Hello everyone. Hello. Okay. Today I will explain the how the process for this for this method based on the method from my understanding from my understanding. Okay. Here, as you can see here, this is the chemical reaction. So this is the chemical reaction based on the equation. This is the chemical reaction of the ethylene, where the ethanol is production is occur. Okay. Here we this is my flow chart for my this is my flow diagram for my block flow diagram. Here you can see this is the Na, this is the Nb, this is the Ne. So Na is the number of mole of ethylene C2H4. For the Nb is the number of mole of water H2O. Here and here it's supposed to be Ne. Sorry, this one is Ne, number of mole of in gas. So we have here is the here. This is my flow diagram. Here is my DOF analysis. For my degree of freedom analysis, we have three unknown number for the Na, Nb, and Ne. So here, then we subtract with the two equation and for the independent atomic balance. Here, and then we minus subtract the one inert relation. So we get 0 DOF. So we can solve this equation. Therefore, for next question from B, I'm using the carbo balance. Why I'm using the carbo balance is much easier way to find the number of mole of A. Why? The number of mole A is the ethylene C2H4. So I'm using the carbo balance, so it's much easier where we can detect using the C carbon here. For here is the C2. So they have two carbon. So 2Na here is the equal to the product here they have 1 2 and 3. So for the C2H4 C2H5OH and bracket C2H5 2O. So we can identify the carbon balance where this one 2 multiply with 0.374 multiply with 100 for the mole basis, and then here 2 0.045 multiply with 100, and then 4 with times with 0.02 multiply with 100 more. So you can get the Na for the mole of C2H4. Next, to find the Nb, I'm using the to find the Nb, I'm using the oxygen balance. So the oxygen balance, uh, I'm using still the same. You just see closely the for the O, how many O there are. Yeah. From this flowchart, they have one O, here also one O, here also one O. So everything multiply with 1. So your NB equal to 0.466 multiply with 100. And then 0.045 multiply with 102, and then 0.002 multiply with 100. So you can get the NB value for the H2O. And then for the inert gas balance is non-reactive, so we can just directly equal to the product. So 0.113 multiply with 100, so you can get the number of mole of inert gases. Next, I'm using another method to find the composition for the reactant. So here y a equal to n over nt. Nt is the number total of the reactant. So the nt from the one we already found from the balance here, Na, Nb, and Ne. So we just add up add up all the number become the Nt and total. So here Na 42.3 divided by the number of total reactant. So you can get the answer for the composition for Ya, for Yb, and Ye. For next is the conversion of ethylene. The conversion of ethylene, yeah, the reactant minus with the product over with the number of mole of reactant minus number of mole of product, uh, divide by number of mole of reactant, and then you multiply with 100%. You can get the percentage of the conversion of ethylene. For the H2O, still the same also. The reactant minus with the product, and you divide by the product, and then you multiply with 100%. You can get the conversion percentage of the H2O. Therefore, we need to find the yield. The yield the desired over with a undesired product. So the desired product that I use is the C2H5OH, C2H5, C2H5 bracket 2O over with ethylene here, the number of more ethylene. So we can get the answer for the yield of the yield, yield of the product. Therefore next is the selectivity. The selectivity I'm using is the number of mole of C2H2O divided by number of mole of ethanol C2H5OH. So you can get the selectivity. Next, the question for this C is about the extent of reaction. This method of extenuation is to identify the exactness between the question before this. If to ensure both of this method is the same answer. So this extent reaction is much special to identify exactness between the question B and the question C. This one question about the extent of reaction. So we can see the exactness between the number of mole, the one we already found, and the number of mole, the one we found right now, using the extent of reaction. Here, extent of reaction, we're using the chemical equation. So here, this is the the formula. Here, I'm using the C2H4, the ethylene, as our first, because the ethylene have the reactant equal to the product, so it's much easier way for us to using the extension to find the extension of what is what, because this first row is 1, so I assume this first row is extension of 1, the second row is extension of extent of reaction of 2. So here, as you can see here, NC3H4 equal to NC3H4.0 minus extension of 1. Here is 1. Okay, so we have found, and then you minus it, and you already get the extension of 1 equal to 4.9. And then next, here, the NC2H5, NC2H5 or 2O is equal to extension of 2 here. Yeah, 2. So we can find this extension of 2. So we jump next to the ethanol and C2H5OH. So ethanol, we can also find the value. So we just make this both a new equation. So here extension of 1 minus 2 times with the extension of 2. Next, for the H2O, yes, we can use it. Why? We have the reactant for the number of mole of reactant and the number of mole of uh, the the product. So here NH2O equal to NH2O dot O minus extension of 1 plus extension of 2 based on this chemical equation. Then we just sub in the number of mole of this product. Here is the reactant, here is the product. So you minus with the extension of 1 that we already found is 4.9, and then you plus with the extension of 2. So minus plus, and then you get already the answer for extension of 0.2. Next, from what? Equation 1, uh, the number of mole of C2H4O 2O equal to 0.2. Here from equation 1, extension of 2 is already been found, so you just sub in, and then you can get the answer directly, 0.2 mole C2H4 2O. So we go up, we just check it here, 0.02 mole of C2H5 2O times with 100, you can get 0.0 0.02 mole of C2H5 or 2O. So our our calculation method is accepted. So it's or is it 0.2? Sorry, I mean 0.2 before this. Sorry. 0.2. Here we have multiplied with the 100, 0.002 multiplied with 100, we can get 0.2. So our calculation exactness using extent of reaction is accepted, complete. Here, our accident fraction is complete. For this one next, we just sub in from the value of extension of 1 and extension of 2. So we can get 4.92 minus with 2 times 0.2, you can get 4.5 C2H5, C2H5 or H. So we go check up again from the flowchart. We can get here 0.045 times with 100, we can get 4.5 mole. So you go check again, So our answer is 4.5. So the answer is the same. So our calculation method is accepted. So that's how the calculation method be used. So that's all my explanation method for this question. So thank you.